Um, I'm going to be doing examples on limits. Pretend I'm given a limit to evaluate. Hold on, let me change the brush size. Let me just erase this. Imagine I'm given the limit as x approaches 1 of x squared plus 2x minus 3 over x minus 1. Now, if I substitute x equals to 1, what you'll notice is that firstly, I'll get a denominator equals 0, but my numerator will also equal to 1 plus 2 minus 3 over 1 minus 1, which is equal to 0 over 0. Now, whenever you're given a limit and you substitute the value of x in, and it becomes 0 over 0 or infinity over infinity, straight away you should know that your limit is evaluatable. This is actually called the indeterminate form. But if you have another number such as, let's say, 1 over 0, this would just be does not exist, or some people like to consider this as infinity. If you have another number such as 1 over infinity, this would actually just equal to 0, or some other people would consider it as does not exist. Now, how do we evaluate this limit, given that I can't just substitute x equals to 1 in there? Well, I could try and factor. So this would equal to the limit as x approaches 1 of x minus 1, x plus 3 over x minus 1. And you'll notice that my x and minus 1's cancel out. And I'm just given the limit as x approaches 1 of x plus 3. At this point, I could just substitute x into this linear function here, and this would just be 1 plus 3, which would equal to 4. Now, let's try a different problem. Let's say I was given the limit of as x approaches infinity, right? We haven't seen that before, of 4 minus x squared over x squared minus 1. Now, before I go over this, I suggest that you give it a shot, pause the video, and have a go at it. Okay, I've assumed you've done that, so I'm gonna go over this. So right away, we can't just substitute infinity in there because I'll just get infinity over infinity, right? And I can't really do anything with that. So let's just try and manipulate this equation, right? So let's just factor out x squared from both the numerator and denominator, right? So x squared of 4 over x squared minus 1 over x squared times 1 minus 1 over x squared. All right, and your x squares will cancel out. And then when you substitute x equals to infinity in here, right, what will you get? You'll get limit as x approaches infinity, or sorry, you'll get 4 over infinity minus 1 over 1 minus infinity. Right, and the squares don't cancel, like the squares don't matter. Like you could write squared here, you could write squared here, but technically it doesn't matter because if I have infinity times infinity, it just equals to infinity, right? If I just multiply infinity by 4, it's still infinity, right? And I want to get a concept down, right? If I have any number divided by infinity, it'll actually go to 0, right? Just think about it for a second. If I take some number, let's say 4, and I divide it by even bigger and bigger and bigger numbers, this number will begin to approach 0. So we consider it as so, right? We consider 4 over infinity to equal to 0. We consider any constant over infinity to equal to 0, right? So in the end, this would just equal to 0 minus 1 over 1 minus 0, which would equal to negative 1. Now I want to try a different problem. What if I had the limit as x approaches 0 of square root of x? Now right away, some people might just think to substitute in it, and then you just get the square root of 0, which would equal to 0. However, I mentioned previously that the limits of both sides must equal to each other in order for the limit to exist, right? So square root of x looks like this, right? And then as I approach 0, from this side, it approaches a finite number, right? However, there's nothing to approach from the left-hand side, right? So we could write it as this. The limit as x approaches 0 from the positive side would equal to 0. However, the limit as x approaches 0 from the negative side does not exist. And then in order for my limit to exist, the left-hand side must equal to the right-hand side. I mentioned that previously in the last video. So this limit in total, we'll consider as limit as x approaches 0 of the square root of x does not exist. I'm going to try one more type of problem, and I like to consider this as a radical problem. And it states that limit as x approaches 0 of the square root of x plus 4 minus 2 over x. Right away, if I substitute x equal to 0 in here, I'm going to get the square root of 4 minus 2 over 0, which would just be 0 over 0. So we're going to try to do some algebraic manipulations here. We could try and rationalize this, right? Or sorry, we're not going to rationalize, we're going to multiply by the conjugate, right? So the conjugate is the square root of x plus 4 plus 2 over the square root of x plus 4 plus 2, right? And we know that from a previous grades, we know that this would equal to a squared minus b squared, the numerator. So my a is x plus 4 squared minus 2 squared, all of that over x times x plus 4 plus 2. And then this would then equal to, I'm running out of space here actually, so I'll make some space here. This would equal to x plus 4. Sorry, you got to write the limit here. X plus 4 minus 4 over x times the square root of x plus 4 plus 2. And then your numerator becomes, I'll create some more space for myself again. I should really write smaller, and I will. Your numerator becomes limit as x approaches 0 of x, right? My 4's cancel out, over x times the square root of x plus 4 plus 2. Your x actually cancel out to become 1, so this would equal to the limit as x approaches 0 of 1 over the square root of x plus 4 plus 2. And at this point, you can just substitute x equal to 0 here, and what you'll get is 1 over the square root of 4 plus 2, which would equal to 1 over 2 plus 2, which would equal to 1 over 4. And that's it. Those are the main three types of problems. You could either get a kind of factoring problem, you could get a radical problem where you have to rationalize, or you could just get a problem where you could just substitute it immediately, right? So for example, limit as x approaches 3 of 3x plus 5, this would just equal to 14, right? Because you just substitute x into here.